Mills have presented and continue to present a serious danger in the rubber and plastics industry. Fortunately, through changes in work practices and safety engineering controls, such as pressure-sensitive body bars and worker training, the incidence of mill nip point accidents have decreased greatly. Injuries from mill accidents can result in permanent disabilities and sometimes death. Because of the nature of these injuries, it is critical for every facility to adopt and practice a rescue procedure that provides a means to remove a trapped and injured worker from the mill in a manner that hopefully minimizes the severity of the injury. After you watch this video, you may have questions concerning the procedures and equipment in your plant. Supervisors, safety representatives, and health and safety committee members can provide you with additional information to address your specific concerns. Before we review mill rescue procedures, let's discuss the basics of a two-roll mill and its safe operation. A mill is a machine consisting of two adjacent metal rolls set horizontally, which revolve towards each other as viewed from above the mill. The rolls of a mill are made in a range of lengths up to 100 inches or more. Small mills are typically used in a laboratory environment to mix small rubber batches. The larger sizes are used when mixing large batches for production. Mills are accompanied by several auxiliary systems that present their own dangers. Depending on the size of the mill, a mill operation may have a second set of blend mill rollers mounted above the main roll set. In addition, there may be a conveyor system feeding rubber into and out of the mill, passing the rubber through slitting knives and guides. These elements also need to be guarded. A mill is used for the mechanical working of rubber compounds and to manage the temperature of the material. The mill process shapes the rubber into flat, long strips by forcing it through the nip of two set rolls. When discussing mills in plant safety meetings or written safety manuals, we often refer to the nip point of the mill. The nip point is a line formed where the two rolls come together. The inward motion of these rolls pulls the rubber through the mill. This same inward motion has the capability of pulling a glove, a knife, or an operator into the nip point. In addition to being pulled into the nip point by the motion of the empty rolls, an operator might be caught in the rubber being worked on the mill and pulled into the nip point. There's also a possibility of slipping or falling into the nip point of the mill. In some other cases, workers have been injured attempting to retrieve tools, such as a glove or a mill knife, which has fallen onto the mill. In a similar way, the nip point of auxiliary blend mills can pull an operator into the nip point. Workers who have been involved in a mill accident often state that they did not have time to react after being caught. Danger from the auxiliary equipment near the mill occurs when handling the rubber strip as it leaves the mill and is fed into the conveying system. Metal hooks, gloves, and clothing can be caught in the advancing rubber, pulling the worker into secondary chemical baths, chopping knives, and drying equipment. Safety around mill machinery begins with the basics. The lighting, ventilation, floor surface, and general cleanliness all contribute to a safe working area. Since the mill area is typically filled with equipment, ensuring the basics are met is a necessary starting point. Today, the most common protective step in minimizing the risk of being caught in the mill nip point are pressure-sensitive body bars. Sometimes this protective device is referred to as a belly bar because the device is installed 40 inches above the working surface, or above the level of an average employee's stomach. This height allows the worker to operate the mill but not reach the nip points. If an employee is caught in the rubber or pulled into the nip point, he or she can stop the mill's rotation by activating the pressure-sensitive body bar. OSHA has mandated a maximum stopping distance based on roll speed. This distance should be determined for every mill in the plant by management with the assistance of the Health and Safety Committee based on OSHA and ANSI standards. Check the mill stopping distance each shift. Newer mills have faster response times and more reliable stopping distances than old mills. Know the stopping distance for the mills in your factory. The stopping distance should be checked daily by each new operator. An emergency safety rope or cable should be used in conjunction with a body bar to stop a roll. It's important to note that a cable alone does not provide as effective a means of protection as a pressure-sensitive body bar. Other safety devices, such as pressure-sensitive floor mats, can be used as auxiliary devices. Some states have stricter safety rules regarding guards and other safety mechanisms. Follow these carefully. Today, some devices have the capability to both stop the mill and separate the rollers at the same time. When these devices are used, pushing the e-stop causes the rolls to open and stop before powering down the system, unlike current practice, which powers down the equipment immediately. Discuss these devices with OSHA if selected. Laboratory mills, those typically under 36 inches in length, present special issues regarding safety. These mills have fewer people nearby, and all sides of the mill are usually accessible, allowing for more opportunities to get caught. Additional specialized safety equipment can be used. In addition to the belly bar, safety rods over both the front and back rollers protect an operator reaching into the nip point, since a belly bar may not be triggered quickly enough. Knee plates, foot pedals, and alarm buttons are also placed in the operator working area, allowing multiple ways to trigger an alarm. When mills are manufactured, means are provided to easily remove a worker if trapped. Each plant needs to develop a method or protocol for such extractions. An effective mill rescue program should include established procedures, which take into consideration proper tools and equipment readily available in the immediate area, alarms that are unique to a mill accident, a trained employee rescue team that understands all the mill types at the facility, available medical and first aid resources. An emergency tool cart or mill rescue cabinet should be located in the vicinity of the mills. It should be designed so that its contents are readily available. Regardless of the procedure being used, some tools are needed. It is important to ensure that the mill rescue tools are inspected regularly so that they remain in proper working order, and that any missing or poorly maintained tools can be replaced. Mill rescue tools should include sledgehammers, pinch bars, wedges, insulated blankets, knives, rubber hooks, a bloodborne pathogen kit and other first aid supplies, flashlight, hydraulic jacks with spreaders and spacers. Keep a checklist of tools for inspection. Each employee should be made aware that these tools are to be used only in case of a mill emergency or a mill drill. The mill rescue toolbox must not be locked, as this could delay rescue. However, some facilities use a breakable lock or seal on the toolbox to discourage unauthorized use of the tools. A rescue team assigned to cover given mills should be selected from among the employees familiar with the equipment and working in the immediate vicinity of those machines on each shift. Once rescue personnel have been trained and the equipment provided, they should hold practice sessions at regular intervals. In the course of such drills, each team should rotate the mill screws involved in the drills. Such rotation will help to ensure that all the machines can be opened the minimum distance required to effect the rescue, and that all team members have practice on all mill types in the facility. The training should be developed with input from all mill operators, Health and Safety Committee, and management. Quick, knowledgeable response can reduce the severity of a mill accident. The members of a mill rescue team must become familiar with the mill rescue tools. Written rescue procedures should be established and posted. Mill employees should be knowledgeable of these procedures. A mill rescue team must be familiar with the actual hands-on rescue procedure and not rely solely on written protocol. When arriving at the scene of an emergency, the mill rescue team may assume its responsibilities for the rescue operation by predetermined assignments. It is important to consider that one of the rescue team members may be trapped in the mill and not able to assume his or her role. Also, other operators assigned to the important roles may be in other areas of the plant or off work. The mill rescue procedures, then, should allow for alternates in all emergencies. Another possible option provides that the rescue team assumes responsibilities in the order that they arrive at the scene. The following sequence depicts a mill rescue procedure utilizing the mill breaking or roll opening method. Following an accident, the safety equipment will trigger an alarm in most cases. Alarms are normally tied into the emergency stopping device on production mills, but might not be on smaller lab-sized mills. If not, a coworker who witnessed the mill accident or found the trapped worker must start the alarm. Whatever the type of alarm used in your plant, it must be distinguished from other plant emergency alarms. The alarm notifies members of the mill rescue team and other plant personnel of the emergency. All nearby equipment related to the mill needs to be stopped if an alarm is triggered. After sounding the alarm, the initial rescuer to arrive applies the lockout/tagout device to the manual reset emergency switch to ensure that the mill is not inadvertently restarted or reversed. The second rescuer offers comfort and support, including restraining the injured if necessary. They will stay with the injured worker throughout the rescue. The next person on the scene brings the emergency tool cart and works to protect the injured employee from being burned by the hot mill surface or hot rubber. To protect the employee from serious burns, a thermal blanket should be placed between the victim and the mill. Using water to cool the mill is not recommended because the steam generated can cause additional damage before the mill cools enough to matter. This person may also be assigned the responsibility of cutting the rubber away from the victim, being sure not to cause further injury to the body part trapped in the rubber. Others should make sure that the tools are properly distributed. A rescue team member should contact appropriate emergency personnel and meet the EMS team on the street to secure the quickest emergency medical services. An accident scene manager is a useful role to establish for the rescue team. Their job is to control non-participating or untrained workers and redirect them away from the accident area. An effective mill rescue involves a rapid but orderly process of opening the mill rolls. Rescue team members must secure and insert the mill bars into the mill screws. The mill screws should then be simultaneously rotated to enable easy removal of the mill caps or plates. It is important to ensure that the screws are lubricated and maintained properly on all mills. The mill caps must be removed to allow sufficient space for additional mill roll movement. If this is not done, it will impede the opening process. These caps provide the means of immediate mill screw clearance. Mill jacks, either permanent or portable, can be used once the mill screws are opened and the mill caps are removed. Where permanently mounted jacks are provided, 2 rescue team members must activate the pump handles. It is important that the pumping action be applied simultaneously to both pumps, preventing cocking of the mill rolls. When sledgehammers and wedges are the primary tools used for opening the mill rolls, or in the event of a jack failure, 2 rescue team members should set a wedge in the mill bite at each end of the mill from the opposite side of the victim. The wedges should be forced into the mill bite using the sledges simultaneously to prevent cocking of the mill rolls. Once the mill rolls have been opened, the mill rescue team members should lift the injured from the mill and administer first aid until emergency medical or other qualified personnel arrive at the scene and assume the responsibility for medical care. Ideally, members of the rescue team should have first aid training enabling them to ensure the worker is breathing, treat for shock, burns, crushing injuries, bloodborne pathogens, and the ability to stabilize the injured body parts to prevent further damage. Specific medical supplies can be recommended by their first aid trainer or other medical professionals. The reactions of the rescue team should be monitored by the scene manager to ensure their continued ability to function in this difficult environment. Now, let's see a rescue drill in real time at a different location. See whether you can find all the elements of a good rescue process. When a rescue is needed, the team members must all know their tasks. Mill size, whether small or large, adds variations to the extraction methods. For small mills, there is less space available to access the mill components, so better team coordination is needed. Also, with small mills, there are typically fewer staff nearby, or the nearby staff does not normally participate in production-focused safety exercises. This needs to be addressed. On large mills, hydraulic motors are often used to drive the rolls. These are large and can get in the way of the roll separation effort. Consider adding additional safety mechanisms, such as automated hydraulic roll opening, as part of the e-stop sequence, or permanently mounted hydraulic jacks in positive pullback, so that the rolls open as the mill screw is opened. Till now, we have mainly discussed the primary mill rolls, but safety and extraction from nearby mill accessories are also important for the rescue team to include in training. Overhead blend mills use many of the same safety mechanisms as their primary rollers. Separating these rolls, though, is more difficult because of their mounting height and placement, several feet above the primary rollers. Trapped workers might be suspended off the ground and need support. The use of wedges and sledgehammers is not simple if there is no platform available. Even the less imposing rubber conveying system needs to be considered in creating rescue team instructions. Cages over conveyor belts, tension cables across feed areas, and similar guards are needed to limit unintended access to the equipment. But if a worker is pulled into one of these, a different set of tools will be needed for extraction. These need to be stored nearby. In companies where mill temperatures are higher, workers are sometimes more seriously injured by the heat of the mill. In this case, the mill may be fitted with mill reversal controls, allowing the rolls to be rotated in reverse to free a trapped worker. This technique is much quicker than the mill breaking procedure, but more complex. Using mill reversal to extract a worker involves detailed knowledge of the mill controls and the ability to jog the mill slowly in reverse. This backwards rotation also comes with dangers. The direction of the mill rotation, the location of the worker above or below the rolls, and the distance the rolls move per jog must all be well marked or configured to avoid errors. If reversal is to be used, specific training and practice by the rescue team is needed. In the end, if the reversal is not successful, the rescue team may still have to open the rolls. Whichever rescue method is used, it should be selected in advance and trained, so a factory rescue team can act without delay or confusion. Accidents happen, but can be minimized by finding and fixing the cause. Once the worker has been safely removed and given medical care, the focus changes to finding the root cause of the incident and implementing improvements and preventative steps. While this is in progress, the machine needs to remain locked out until incident details are collected, machine performance and safety mechanisms are checked, surfaces are cleaned and disinfected, and improved practices can be established and put into place. You may also want to consider post-incident counseling services for the affected staff. Since prevention of future incidents is most important, any defects relating to the machine hardware or safety mechanisms must be added to the preventative maintenance schedule for the machine. During an exercise like a mill rescue drill, much activity occurs in a short time period. It is important to spend time now becoming familiar with the proper procedures so that the few minutes following an accident go smoothly and the operator is freed from the mill as quickly as possible. Each of us can do our best to prevent accidents such as these in our workplaces. When an accident occurs in a plant, there are more than likely many factors that contribute to its cause. A mill rescue team must be prepared to respond to various types of incidents on any mill in the plant. We all share one common goal. We all hope to leave work every day in the same condition as when we arrived. Just as importantly, we all want to ensure that procedures are in place and personnel are adequately trained to properly respond to emergency situations in order to minimize the severity of a coworker's injuries.